G'day guys and girls, Ben here, just doing a quick video on the Tickler relay and a step-up transformer setup. Just to quickly explain what I've got here in front of me. I apologise, I've had to lower the image quality of the video due to YouTube basically stuffing me around. I had a couple of failed downloads last night, so there's 6 hours down to Dunny. What I've got here is 240 volt input AC 50 Hz. Going through a 2 amp fuse or circuit breaker, and now I've got my 240 volt fused output. Over here I've got a multi-tap transformer, comes out of a washing machine. I've got it on a 0 and the 240 volt primary input. Here for safety I've got a earth bond to my earth terminal block and then out to the earth on the incoming line. This transformer's, like I just said, multi-tapping. It's got a 0, 11, 14 volt secondary, and it's also got a 0 and 14 volt secondary, which is on these two white wires. They won't be used in this demonstration. They're basically for me and testing purposes for other equipment. So what I'll do is, I've got it on the 11 volt tapping AC. So I'll turn this on and I'll just quickly probe these two alligator clips. If you look at my meter, we've got 11 volts AC output. What I've done also is I've built a very basic bridge rectifier. I've got a standard can package bridge rectifier with a capacitor across the output terminal, just for very crude and basic smoothing of the DC output. So I've got my two AC input lines coming in, which I haven't connected yet, and I've got DC coming out with a crude power filtering capacitor. Here we have a basically second-hand ex-stock laying around that I've got. It's an Omron single pole relay on an Omron base. We've got our two coil contacts. Now this might not come up in the video too well, but just bear with me. Two coil contacts. We've got a normally closed contact, a normally open contact, and we've also got a common contact. Now because this relay is on a double pole base, basically these three contact lines are jumped across, so I'm only going to use one side of it. So this is wired up in a Tickler relay mode at the moment. So what I've got is I've got my 12 volt DC coming into my normally closed contact, then it comes out of my common contact, and I've looped this into the positive of the coil for the relay. Also what I've got is I've got a neutral or 0 volt line coming into the other side of the coil. So we've got our power turned off at the moment. What I'll do is I'll plug in my 11 volts AC onto my standard package bridge rectifier. Now these are good for about 40 amps. I'm not going to be using anywhere near 1 amp, half an amp, quarter of an amp for this demonstration. So completely overkill, but it's what I had laying around. So what I'll do now is I'll turn it on and immediately you'll hear the relay start buzzing. Now if I push the relay onto the desk, it gets a little bit louder. If we turn the relay on the side, you won't see it in the camera, but you see I can see the contacts in there, and there's a nice blue arc between the normally closed and the common terminal. Now with this nice blue arc in between the two contact points, the arcing is going to pit, dirty up and carbonise the contacts. So this type of relay is not, well, this setup for this relay is not very good for long-term efficiency. These two contacts will start to increase in resistance over a period of time, and they will get to the point where the voltage drop across those two contacts will be quite significant, and you'll see your project starting to fail. Okay, so I'll just turn it back on again. Now this relay is buzzing. Now what happens if I jump my 12 volt DC input across to the coil, the relay stops and energizes fully. So this, at the moment, with this black jump wire, is effectively jumping out the latching and unlatching of the Tickler relay. So this relay is energized at the moment. If I let it off, it'll go back into oscillating, put it back on, the relay's on. Pretty straightforward. Now the other thing that the video that in reference to this is all about, excuse me sweating, it's about 43 degrees here at the moment Celsius, so it's quite sticky and hot. They're talking about having a electroluminescent display across the coil contacts, which is basically being powered by the back EMF of the coil and the magnetic field expanding and collapsing, creating a high voltage. Now with the digital multimeter, if I put my probes across the terminals, I'm still going to see 13 volts. Now there is a fault, not a fault, but a known problem using digital sampling multimeters, that the sample rate sometimes is not good enough to see the highs and the lows of the voltage or the actual physical voltage. If you wanted to check your, we're going to call it back EMF voltage coming across the coil contacts into our electroluminescent display. I've got one around here in the house somewhere. I'm renovating and I can't bloody find it. In that case, what I would be using is a analog needle meter. The analog meters are not worried about a lot of the frequency and the sample rates problems with the Fluke or any digital multimeter. So hopefully I've explained that alright. Now what we'll do quickly is just do a quick demonstration on a step-up transformer. So we'll just put that aside for the moment. Now what we're going to do is look at a step-up transformer. I've got a cheap Chinese $7 transformer from a local electrical supply shop. 240 volt AC 50 Hz input. Our secondary tappings are 0 or neutral. Our midpoint tapping is 6.3 volts and our full tapping is 12 volts. So what we're going to do is we're going to drive this transformer in reverse. So I'm going to hook up the secondary out of our primary transformer to the secondary, which is now the input side of our transformer. So if I take our 0 volt line and connect that to the neutral of that, and if we take our 12 volt line, connect it to that, now the midpoint 6.3 volt tapping we're not going to worry about at the moment. Here I have is just another on-on relay, 240 volt AC coil. It has got a LED or a neon indication to tell us whether it's on. This is just for testing purposes so we can actually see what's going on. So now what we're going to do is turn the system on. We can see our neon is illuminated. So we'll just go through the circuit quickly and just prove some voltages. Okay, here we have 12 volt or 11.1 volt AC input into our step-up transformer. And if we look, we've got 180 odd volts secondary coming out of our step-up transformer. Okay, so this is using a standard step-down transformer in reverse to get our higher voltage. As you can see, you might not be able to see, but the neon is on, and we do have an AC voltage a lot higher than what we're putting into it, so effectively it's working. Now what would happen if we changed our tapping to our midpoint center tapping? Now the relay is on a little bit brighter this time. Now if we probe our output, we've now got 310 volts. Okay, hopefully this will quickly demonstrate step down transformers and step up transformer, which is a step down transformer used in reverse. Pretty straightforward. Hope it helps.